I said, okay, hey guys, we're doing Pythagorean Theorem. So what we've done, and you have the drawing already. You don't have to draw it if you've been absent. So what we learned is the area of the smaller one was 9. The area of the middle one was 16, and the area of the largest square was 25. And Caitlin just told us that 9 plus 16 gave us 25. And I asked, do you think you always add the two smallest ones to get the largest one? And somebody said, what do we all say? I'm thinking you do. I'm thinking you do. Okay, so let's go do another one. So I need you to take the next 3 sizes, put those 3 to the side. Take the next 3 sizes. The next 3 sizes. And see if you can do the same thing. Well, don't start drawing till we figure it out. Because you might not have it on there right. Yeah, we're going to put it underneath this one. Yes. We got one to do on the back, so we can't go to the back. And it can fit on there, guys. I promise. Yeah, you're going to make a right triangle. That's the whole lesson. Y'all figured it out? Okay. And hey, which 2 squares did you put together to make the right angle? The 2 smaller ones, right? The 2 smaller ones. Oh, we've got to do something up here on this one. Put our right angle in there. We're going to come back and we're going to fill in. Okay? So, you took the what? Talk to me. What'd you take? Tell me the sizes. Tell me the sizes. Okay, I won't turn it this way just to have a different. Okay, the 6 by 6 and the 8 by 8 and the 10 by 10, right? I'm just turning. Oh, let me fix it. I'm going to turn it a little bit. So, I'm turned it so my right angle is over here just to show you can do it different ways. It doesn't have to be always. What? Yeah, 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 yeah. Remember, once you know where it's going to be, you can pick your square up. But the largest one you have to trace around because God bless you. And then label the areas. Okay. What's the area of the smaller one? Smallest. Good. And the next, did y'all test it to make sure? And this one was what? 100 centimeters squared. Did y'all test to see if 64 plus 36 gave you 100? Good job. And here's your right angle. Okay, let's go back up to the top one, and let's write down the theorem that Mr. Pythagoras figured out. He figured out that a squared plus b squared gave him c squared. Now, what in the world is a, b, and c? What do you think? Maddie? So what do you think that? What are we going to put in for a? What are we going to substitute in for a? 9. We're at the top one. 3. Because why are we going to do 3 squared? How do you get area of a square? Side squared. Side times side. So, A is going to be, everybody go put A is 3 right there. A is 3. We're going to come back and talk about it. What do you think B is going to be? 4. So come put B is 4. Then what do you think C is going to be? Well, 5, huh? Just 5. So C is 5. So what do the A, B, and C tell us? What does A, B, and C tell us? The original area of it? Well, the original area, there's only one area, which is 9. The what? Original size? No. Why does A equal 3? Why does B equal 4? What is the 3? It's the, thank you, Megan. It's the side length, guys. Sean, the A, B, and C tell us the side length. We're going to use this theorem today to prove that what we're doing makes a right triangle. But tomorrow, we're going to use that theorem to find the length of one of the sides. You're going to have a right triangle. Listen, you're going to have one right triangle. You're going to have 2 of the sides, and you need the third one. That's what my brother and I did. We knew the 2 sides needed to be 3 and 4, but we knew that we needed that side to be 5, 3, 4, 5 rule. So we had to put the string where it would meet. We knew that this side had to be 3 and this 4, but we had to put the string where they touched the corners. And when we knew that and this was 5, we knew that then we had a right angle right there. We just took the string, 5-foot string, and we knew when we got that corner to that corner, these were in the right place to make that right angle. Okay? So, and girls, don't you think, oh, I'm not ever going to be a welder, or I'm not going to need that. You might be a math teacher. You might be helping your child with homework. You might be helping your brother figure out how to make a right angle. Okay? Miss Kent can tell you she does all kinds of stuff at home with her husband, building and all setting posts and all that. This is going to come in handy one day. You're going to be glad you know it. Okay, so right up here, we're using it to prove. But A, B, and C are your lengths of your sides. And so when I take the 3 and I square it, I'm making the area of that square that goes off of that side. And then 4 squared is 16. And then 5 squared is 25. And when I add the 2 areas, I've got to get 25. When I do, I know I've got a right triangle. I've got a right triangle. So I know that 3, 4, 5, if those are the lengths of my triangle, I've got a right triangle. It's going to be just like I want if I want a right triangle. or if I want a right angle right there. Okay? Now, let's talk about, okay, do you think, okay, this right here is right across, draw an arrow. That's right across from your right angle. Do you think that long side is always going to be across from your right angle? Let's look at the bottom one. Here's your right angle. Draw an arrow to it. Is that the longest side? Is that the longest side of the largest square?
Yes.
So that's what it's going to be. So side C is always going to be your longest side, which is called a big O word. Draw an arrow, because we don't even have to write it in there. Draw an arrow to it. This is called your hypotenuse. Hypotenuse. And you know what? You're going to remember that. Think of a hippo. Think of a hippo. It's large, right? That's how I always remembered it. Okay, so hypotenuse is always your longest side, which is across from your right angle. Hey, this is one of the things that if you can remember this, you're good to go. Right here, find your right angle, draw an arrow, that's your side C. Now, these two sides that make the right angle, these are called your legs. That's a leg, and that's a leg. And they're always going to be your A and B. Now, the ones we do together, we're going to call A the shortest side, just so we'll have the same problem. But if you're doing it by yourself, if you don't want A to be the shortest side, you can put B for the shortest side. But A and B have to be the two legs. It doesn't really matter which one. Okay, that's the second thing. Okay, so we got the one thing. The first thing, what do you got to remember? Side C is what? The longest side across from the right angle. If you can remember that, that's good. Second thing you need to remember, A and B are the two shorter sides. Okay? You got that? Okay. Now, come down here at the bottom. Let's label. What's A going to be? What's this side length going to be right here? That's the shortest side of the right triangle. Look, guys, right now what I'm focusing on is the right triangle. Good. A is 6. What's B going to be? 8. And what was C? What's the square root of 100? Square root of 100 is...
10.
Guys, it had to be bigger than 8. Right? Because it's the longest side. Hey. The longest side is always the longest side. I'll have kids that get 6, 8, and they'll put 5 there. If C is the longest side, I know for a fact it's going to be more than 8. True? It's got to be more than 8. So let's think about that, okay? So let's go use the theorem to prove it. A squared plus B squared is C squared. So what's A? Well, 6, right? And so we're going to square it in a minute to get the area. And then 8 squared equals 10 squared. All we're doing is substituting the side lengths. Look, I'm putting 6 in for A, 8 in for B, 10 in for C. And I'm proving that it does make a true statement. So 36 plus 64 equals 100. And what's 36 plus 64? 100. 100 equals 100. Check. I told you. Okay, turn on the back. Now you're going to take the two largest triangles. Squares. I call them triangles. I don't think I did second period, but okay, the two largest ones. And then you're going to find one of the ones you've already used that's going to go with these to make a right triangle. So you got to figure out which one of the ones you've already used is going to fit in here to make it a right triangle. A right triangle, yes. And we're going to, hey, to make it fit, look, people, hey, you have to turn your paper sideways. Hot dog. So keep looking. If Kent are going to come by, and if you think it's right, raise your hand. I'm going to turn off the thing, guys. In there, y'all. Okay, it was the 5 by 5. Okay, so side A. Side A. Somebody, side A. So what's the area of that square? Oh, hey, draw your right angle, and let's draw an arrow over there. That's side C. B is what? B is 12. So the area of that square is what? No. 144. And then C is 13. The area is 169. Okay. So let's come up here. Get everything labeled. The side lengths labeled and the areas labeled. Okay, let's use the theorem. Everybody should be at this point. Let's go. Okay, what's A? So 5 squared plus 12 squared equals 13 squared. 25 plus 144 is 169. 169 equals 169. Check. Okay, put that to the side real quick. Look at your other paper on D73. Okay, put both of those papers in practice. Put your squares in the paper clip. Thanks, Mason. Okay, we're looking at the back of that paper I gave you, D73. I'm going to do D. Why do adults complain so much? They just do. Okay, look at this page and find one. Now, see, you have right triangles. Very seldom are you going to have the squares drawn on the right triangle. They're just going to give you a right triangle, and you have to get the length of the side. And that's what this paper is on D73. You have to find the length of the hypotenuse. They're going to give you A and B. So find the one that we already know we don't have to do any work on. Which one? Number 1. So A is 3. Come on. B is 4. C's got to be. Guess what somebody said this morning? C was going to be 7. How'd they get 7? They had 3 and 4. Guys, if it was that easy, I wouldn't have cut out all these squares and we wouldn't do the theorem. If all you had to do was add the 2 shorter sides to get the longest side, that we wouldn't need to do a theorem. Okay, so what's the square root of 25? 5. So E. 1 is E. Do the riddle as we go. So, look, guys, let me just kind of go over this again. So, if you take side 3, this side that's 3, and you draw a square off of it, that's going to be 9 squares. And then you draw a square over here, that's going to be 16. Plus the 25 gives you 5. Square root of 25 is 5. Okay, now there's another one. That we don't have to do any work for. We already know. 11. We just did it, didn't we? So, A was 5. B is 12. See, there's your right angle, and C is across from it. So, C was what? 13. So, the square root of what gave us 13? 169. The third one, Y. 11 is Y. Good job. There's one more. There's actually 2, but there's one more that we drew. 8. Number 8. So A is 6. You're welcome. B is 8. And across from the right angle there is C. C is 10. Remember, 3, 4, 5. If you double 3, you get 6. You double 4, you get 8. You double 5, you get 10. So this follows the 3, 4, 5 rule. One student one year said that their uncle, I believe, was a carpenter, and he called it the 6, 8, 10 because they used 6, 8, 10 more than they did 3, 4, 5. I've never heard that, but okay, hang on just a minute. So square root of 100 is 10A. 8 is 8. There's one more that you should be able to look at and find. Avery found it. Which one? Okay, why 5? She said it, Mason said. She said it. 3 times 3 is 9. 4 times 3 is 12. So A is 9. B is 12. So C is going to be 15. The square root of what is 15? 225, T. So 5 is T. Yeah, it's not a code key. It's answers. When it says code key, you don't cross them off, but yeah. All right, there's one more I want you to find. Not 3, not 2. No. 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 15. Look at 15. Oh, come on, people. 15. So A is 30. B is 40. C is going to be 50. And the square root of what is 50? R. 15 is R. Very good. 2,500. Okay. Now, for some reason, guys, after we learn this, and everybody learns it, I give them a right triangle, and they need to find the length of the side, and guess what they think? Oh, that's 7, 9, 11. 10, 10, they'll put 15 or they'll put 20 there. They just start doing this crazy stuff. Remember, 3, 4, 5. If you have 3, 4, 5, and you multiply 3, 4, and 5 by a certain number, you could find another right triangle. Or that 5, 12, 13 is one that I always had trouble remembering because it's weird. 5, 12, 13. Okay? Alrighty? And then there's one more you're going to learn, but not today. Okay, so we're gonna put this. I just meant. All right. Okay. So, does everybody understand what we did? What the A squared plus B squared C squared? What are we going to use it for mainly? to find the length of a side of a right triangle. It's got to be a right triangle. It has to be a right triangle. Yeah. Well, yeah, we could. You're right, Mason. Mason said you could find any side. Yes. Yeah, not just the hypotenuse. You could find A, B, or C. We're going to use this. Okay? Does everybody get it?